Okay, guys and girls, continuing, we're on page 8. If you notice, what we've got here is a little chart that's showing some of the polygons that we've already talked about. What we're going to be doing is see if we can come up with some sort of rule or pattern when we're counting the angles inside the polygon and what the sum of those angles would be. And we've already talked about this on the last page. If I added this angle plus this angle plus this angle, these three, regardless of what type of triangle, would add up to 180 degrees. Again, it could be a right triangle, could be an isosceles triangle, doesn't matter. Well, now that we know that all triangles, the three angles add up to 180 degrees, what we can do is we can take a quadrilateral, and if you look at this, what we would have there is two triangles. We would have one triangle, two triangles, and it doesn't matter. You could have a weird quadrilateral that looks like this. We could still cut that into two triangles, and each one of those triangles would have a sum of 180 degrees. So now we have two triangles, and each one has a sum of 180 degrees for the three angles inside. So any quadrilateral, if I added these angles inside of a quadrilateral, they're going to have 360 degrees, the total. No matter what kind of quadrilateral, rectangle, kite, trapezoid, you add the four angles in your calculator, you're going to get 360. Well, it starts to get a little more complicated when you have a pentagon or hexagon or some of these other, more than four sides. So what we can do is use that knowledge that we have about the three angles inside of a triangle, and let's just think about this. If we come from one vertex point and we cut this shape into X number of triangles, if you notice, look what we have here. This pentagon can be separated into three triangles. Well, we already know that the three angles inside of a triangle add up to 180 degrees. Well, this pentagon, if we cut these into pieces, we have three triangles that add up to 180 degrees. So no matter what five-sided polygon you have, if you add the five angles inside that polygon, you're going to get 540 degrees. Well, let's see if we can do that for a hexagon as well. So now we have a hexagon, and again, let's just separate this into triangles. So if you notice, there's 1, 2, 3. Now a hexagon can be separated into four triangles. Well, we have four triangles, and all of these triangles have 180 degrees when you add up the three angles. So that means that when we added up the six interior angles of a hexagon, we would get a sum of 720 degrees. Well, now we have this weird heptagon, which is a seven-sided polygon. So let's see if we could just get these into some triangles. So there's 1, 2, 3, 4 lines, but look what happens here. We now can cut a heptagon into 5 triangles. And we, again, know that the sum of the interior angles of a triangle add up to 180 degrees. So that means any seven-sided polygon, if you added up the interior angles, you're going to get a sum of 900 degrees for all 7 angles. Well, I think hopefully now you've seen a little pattern that's emerged. You can draw the triangles if you want to, but most of you have already seen that we're going to be able to get 6 triangles inside that octagon. All 6 triangles are going to have a sum of 180 degrees. So any octagon, the 8 angles inside are going to add up to 180 degrees. Again, there's 1 triangle, 2, 3, 4, 5 lines, but if you notice, we've got 6 triangles. Well, now look at what's going on. We've got an entagon. This one just happens to have several sides. We need to come up with a rule that doesn't matter what number of sides we have, we can use this formula and we don't have to draw triangles anymore. Well, if you notice, 8 sides, how many triangles? 7 sides, how many triangles? 6 sides, how many triangles? So it looks to me like there's a pattern that's emerged here. So what I want you to do is come up with a rule down here at the bottom. Think about a way mathematically you could come up with, if I gave you how many sides this polygon has, you could plug it into this formula without drawing triangles and figure out the sum of the interior angles. So this is going to be a big formula that you'll use especially in high school and maybe in your 7th and 8th grade math classes. So think about this. The number of sides that we have, let's call that n or x, or most of the time you'll see it as n. Well, that's the number of sides, where n is equal to the number of sides. Well, if we subtract 2 from that, that will be how many triangles that will be in the interior of that shape. Now think about what we did once we figured out how many triangles were up there. Of course, what we did is we just multiplied by 180 degrees, and what that will do is that will give you the total number of degrees in the entire polygon. So this formula, this is a big formula in math, n minus 2 times 180. And what that formula will do is give you the interior angles that add together the sum of the polygon that you're looking for. Stay tuned.